Everyone. Today we will continue our discussion. Uh, Today we will solve the real analysis part. Okay, let us continue it. Let us move to the question number 21. In this question, it is asked the union of arbitrary family of open set is what? Whether it is a closed set, it is open set, closed and open set, neither open nor closed set. Okay. But if we take arbitrary means what? Arbitrary means it may be finite, infinite, countable or uncountable, anything it can be. But if we take two four open sets means 0 1 open interval union 1 2 open interval, it gives what? It gives 0 it gives a open set because every point is a interior point. So union of two open set is open set, it cannot be closed. So option B is looking like true and option A is false. Option C is also false. And it is a standard question in real analysis that arbitrary union of open sets is a open set. We can prove it. Let us move to the proof part. Suppose we are given that arbitrary union of open set alpha belongs to I be any index set U alpha. We have to prove that this union is a open set where U alphas are open set. U alpha is a open set. Open set. Okay. We have to prove that union of U alpha, arbitrary union of U alpha is also open set. Okay. Let us move to proof. Okay. Give a name that G equal to union of alpha belongs to I union of U alpha. Open sets means what? Open sets means every point is a interior point. We have to prove that any arbitrary point of G is a interior point. Let any arbitrary point x0 belongs to G. What G is what? G is the union of alpha belongs to I U alpha. The claim is what? Our claim is to show x0 is an interior point. Interior point. Okay, we have to prove this one. X0 belongs to union of alpha belongs to I U alpha. This implies that x0 belongs to U alpha dash for some alpha dash belongs to I. Okay, and we know that U alpha is an open set and x0 belongs to U alpha dash. This implies that x0 is an interior point. Why x0 is an interior point? Because our as U alpha dash is an open set. Okay, so every point of G is an interior point. This proves that arbitrary union of open set is open set. Okay, therefore the correct answer is option B. Arbitrary union of open set is open. Okay, option D is also false. Let us move to the question number 22. In this question, it is a standard question. It is given that S and T are subsets of real numbers. Then S union T complement is what? This question is usually asked in the 11th level or 12th level question. Here it is the statement of the De Morgan's theorem. S union T complement is equal to S complement intersection T complement. So option A is true. Option B is false. Option C is false. Option D is also false. You can take some counter examples. You can discard all the options. And it is a standard statement that S union T complement is equal to S complement intersection T complement. Okay. Let us move to the question number 23. 23, this set of real numbers R is open close. This set of real numbers R, we know that it is both open and closed. It is open is true, it is closed is also true. but open as well as close, this is a more appropriate answer because this answer includes both A and B. So option C is true. Okay, this is okay. Let us move to the question number 24. The set of all order pair of positive integer is what? The set of all order pairs of positive integers. We know that integer set Z is a countable set. Okay, and the product of two countable set is also a countable set, so it cannot be uncountable. So option A is false, option B is true. It is not a finite set, it is infinite set. Option is uncountable and finite. This is also absurd and it is not true. Okay, answer B is true. Let us move to the question number 25. A necessary and sufficient condition for the convergence of a subsequence is that it is bounded. If a necessary condition, necessary and sufficient condition for the convergence of a sequence is that it is bounded, and if a sequence is convergent, then we know that the limit of the sequence is unique. So it should have unique limit point. It should have a limit point which is also unique. Has no limit point is false. Has finite number of limit points, it is also false. Has unique limit point is necessary. Okay, this one. So option C is true. Has infinite number of limit point, this is also false. Okay, let us move to the question number 26. Question number 26, we have to compute the limit. Okay, let us move to computational part. In the question, Bn is defined in this way: Bn equal to 1 by n square plus 1 root over, okay, plus 1 by n square plus 2 root over dot 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 1 by n square plus n root over. Bn is defined. It can be written in compact form in this way: summation k from 1 to n 1 by n square plus k whole root over. Okay. To find the limit point of Bn, we will mainly apply sandwich theorem or squeeze theorem. Okay, this sequence Bn can be can be written in this form like that: Bn less than equal to n by n square plus n whole root over less than equal to summation k from 1 to n 1 by n square root over n square root over. This is true. Why? Let us check it. Because if we consider that these two inequality, each term of Bn is 1 by n square plus 1 root over less than 1 by root n square. So we can 1 by n square plus 1 is less than 1 by n square root over, because in the denominator, when the denominator is less, then the value of this whole quantity will be greater. Here the denominator is bigger, so it is a smaller quantity and it is a larger quantity. Similarly, every term of this Bn is less than equal to 1 by n square root over. So this inequality is true. Okay, let us verify this lower bound inequality. In this lower bound inequality, we know that each term of Bn, consider the 1 by n square plus general term 1 by n square plus k root over. Okay, this term is bigger than which term? This term is bigger than 1 by n square plus n, because here the highest value of k is n. If we take the highest value, then this denominator is a bigger quantity. If the denominator is bigger quantity, then the whole quantity is a smaller quantity. Okay, so and if we add all these what are the number of terms in this Bn? There are n number of terms. If we add all these n number of terms, we will get n by n square plus n root over. So this lower bound is also true. Okay, then we will next, what is our next target? Okay, let me write. If we will sum this quantity, we will get summation. Let me write in other way. Finally we will get n by n square plus n less than equal to Vn, which is less than equal to summation k from 1 to n. 1 by n square root over is nothing but 1 by n. If we will add 1 by n times, then it gives 1 by n plus 1 by n times, then it gives n into 1 by n into 1 by n, which is nothing but 1. Okay, then we will show that this limit, if we will apply, then finally we will get n by n square plus n less than equal to Vn less than equal to 1. Then we will take limit on both sides, limit on every quantity. Then it gives limit n tends to infinity n by n square plus n whole root over less than equal to limit n tends to infinity Bn less than equal to limit. If we take the limit of 1, it gives 1. Okay, then the limit of this quantity, if we'll if we'll take common n, then it gives 1 by n. If we'll take common n square from this square root, it gives 1 plus 1 by n whole root over, or this the limit n tends to infinity Bn and less than equal to 1. Okay, then this limit 1 by n goes to 0 when n tends to infinity, so it is 1 by 1, which is equal to 1 less than equal to limit n tends to infinity Bn, which is less than equal to 1. This implies that limit n tends to infinity Bn is equal to 1. So we get the limiting, what is the limiting value of the sequence Bn is, it is 1. Therefore in the option the correct answer is option D. The limiting value is 1. Okay, let us move to the question number 27. In this question, f of x is defined in this way. Here the critical point is 2, breaking point is 2, because it is a piecewise polynomial functions. It is 2x minus 3 is a straight line, and this is also x square minus 3 something like parabola, and this is a piecewise continuous functions, but we do not know it is whether it is completely continuous. Because the breaking point is 2, we have to check that whether this function is continuous at the point x equal to 2. If we put x equal to 2, and then the left side gives you 2x 2 into 2 minus 3, which is equal to 4 minus 3 equal to 1, and the right hand side, if we put 2 x, it gives 2 square minus 3, which is also 1. Okay, so this function is continuous at x equal to 2. Okay, let us calculate the derivative of f of x. It gives f dash x, which is equal to derivative of 2x minus 3 is equal to 2, and the derivative of x square is 2x. X square minus 3 is 2x when 0 x less than 2. Okay, and it gives the other part. Okay, if we will put the derivative at x equal to 2, then it gives the LHS, we will get LHD will get, it is 2, but RHD gives RHD, right hand side derivative gives 2 into 2, which is equal to 4, but LHD not equal to RHD. Okay, so it is not differentiable at x equal to 2. So it is the right answer. The function at what it is also asking at x equal to 2, the function is not derivable, means differentiable. This is the right answer. Derivable is false. Not continuous, but it is continued as x equal to 2. Derivable and continuous, this is also false. Okay, let us move to the question number 28. In the question number 28, the function is given f of x equal to x minus 3 whole to the power 5 into x plus 1 whole to the power 4. We have to check the whether this function is maximum at x equal to 3 or minimum at x equal to 3, or neither maximum nor minimum, or has a point of inflection at x equal to 3. We have to check this. Okay, let us move to check it. Given that function is f of x equal to x minus 3 whole to the power 5 x plus 1 whole to the power 4. Before going to calculate the whether it is a point of maximum, minimum, or point of inflection, all these points are called the critical points. First of all, we have to calculate the critical points. What are the critical points? For that reason, we have to calculate f dash x. F dash x equal to, if we will apply product formula, then f of 5 into x minus 3 whole to the power 4 uh, times times x plus 1 whole to the power 4 plus x minus 3 whole to the power 5 into 4 times x plus 1 whole to the power cube. Okay, if we take common x minus 3 whole to the power 4 times x plus 1 whole cube, we will get 5 times x plus 1 plus 4 times x minus 3. Okay, and from this expression it is clear that uh, for to calculate the critical point we take usually f dash x equal to 0. If we take f dash x equal to 0, then x equal to 3 is a critical point. Okay, clearly x equal to 3 is a critical point, no doubt. But to calculate whether this is a point of maximum or point of minimum, we have usually calculate f double dash x. If we calculate the f double dash x, then you will find that f double dash x, you can calculate it easily, but here I am not calculating. If you find it x double dash x at x equal to 3, it also gives 0, so we cannot apply the second derivative test. Okay, to judge whether this is a point of maximum, point of minimum, or point of inflection, because when f dash x equal to 0 and f double dash x this is greater than 0, then it is a point of minimum. Okay, minimum if x0. Okay, but when f dash x0 equal to 0 and f double dash x 0 less than 0, then it is a point of maximum. But when f double dash x itself f double dash x 0 is equal to 0, then we cannot say anything, means second derivative test fails. So how can we judge? We can judge from its neighborhood analysis. Okay, let us analysis its neighborhood analysis. Means if we look at the function, let me look neighborhood analysis, we can do f of x is defined in this way, that x minus 3 whole to the power 5 and times x plus 1 whole to the power 4. Okay, if we will given that x equal to 3, at x equal to 3 we are calculating x equal to 3. If we go, if we neighborhood is this one. Okay, if we go from left to the x minus 3, the graph of the function is means x is less than 3, this quantity is a negative and it is a odd power, so the x minus 3 whole to the power 5 is something a negative quantity. Okay, but x plus 1, this is a positive quantity because x is slightly less than 3, it cannot be negative. Okay, this is a positive quantity, so f of x less than 0 in 3 3 minus delta to 3. Okay, in some delta neighborhood we get this one. Okay, and f of x greater than 0, if wait, now we will analyze what is happening on the right hand side of this point x at x equal to 3. If we go slightly in right part, means x is greater than 3, this is a positive quantity and this is a clearly a positive quantity, the product of two positive quantity is positive quantity, so f of x is greater than 0 in 3 to 3 plus delta. Okay, and at the point 3 it is 0, means its graph is something like that, its graph is something like that. At the point 3, at this point x equal to 3, x equal to 3, it is 0, and after 3 it is positive something, and before 3 it is negative something, so it is called the point of inflection. Point of inflections means it is neither maximum nor minimum, because it a point is a maximum or minimum means in some neighborhood it is maximum or minimum. This the value of the function should be either maximum or minimum, but in every neighborhood at x equal to 0 we will get that if we uh, in the left side of this neighborhood it gives negative means 0 is not a minimum. In the right hand side it gives positive means 0 is not also a maximum point, so it is called the point of inflection. Point of inflection. So by using the neighborhood analysis, okay, so by using the neighborhood analysis we got that x equal to 3 is a point of inflection. Therefore the correct answer is option D. Option D is the correct answer. It is not a maximum, it is not a minimum, it is neither maximum nor minimum at x equal to 3, has point of inflection at x equal to 3. But this is also true, but more true is this one, because its second derivative is also 0. Okay, neither maximum nor minimum, no doubt, but has a point of inflection. It is a true, because second derivative is also true. Okay, more appropriate answer option D. Let us move to the question number 29. Okay, in the question number 29 it is asking that f of x equal to 1 by x, this function is uniformly continuous, not uniformly continuous, continuous, not continuous. Okay, no doubt the function f of x equal to 1 by x is continuous, because there is no critical point, because 0 is not creating problem, because here 0 is given open interval, 0 is not included the interval. Okay, so it is a continuous function, no doubt. Let us discard the uniformly continuous, because it cannot be uniformly continuous, because the function is this is a bounded domain, but the function is getting unbounded at the neighborhood of 0. When x going closer to 0, the function value is going to infinity, so it is creating the problem. So for that reason it cannot be uniformly continuous. Okay, this is, so the option C is true. But if you can also apply the usual definition of the uniformly continuous for a given epsilon greater than 0, f of x minus f of y mod less than epsilon, for a given epsilon we can find delta, which is independent of point xy. But if we apply this concept here, we will get that 1 by x minus 1 by y mod less than epsilon. This implies that uh, x minus y mod less than epsilon times xy. You will get this one. But here x you cannot you cannot choose any delta which is independent of epsilon and independent of the point xy, because if this xy quantity goes closer, means if you choose xy near the point 0 0, then this epsilon times xy is a very small quantity. You cannot find a uniform delta that this is less than delta, because if you took any delta 0, then you can find xy which are very small. Okay, then this will create problem. This quantity is always less than any delta, so you cannot take any uniform delta which is independent of the point xy, so it cannot be uniformly continuous function. Okay, therefore the right answer for this question is option C. It is not uniformly continuous, uniformly continuous, continuous, not continuous, but it is a continuous function. It is a continuous function, not continuous is false. Not uniformly continuous is also true, uniformly continuous is false, and continuous is also true. These two things are creating problem, but we have to check what is the more appropriate answer, because uniform, not uniformly continuous, continuous. Okay, these two answers are correct, but here the question is not looking like this option is giving two answers. It is a, because f of x equal to 1 by x is a continuous functions, because here 0 is open interval is there. If it was closed interval, then it will that definitely that not continuous. Okay, and it is also not uniformly continuous. But usually this question is asked for the not uniformly continuous. For the exam point of view, if you are getting ambiguity, then you should choose that it is a not uniformly continuous, because it is clear that it is a continuous function, no doubt. Okay, so in my opinion, more appropriate answer will be this one. If some student is also taking an appropriate answer is C, this is also true. Okay, let us move to the question number 30. In question number 30, in any interval containing 0, fn, the sequence fn, which is defined in this way, fn x equal to nx by 1 plus n square plus x square, whether it is uniformly convergence, not uniformly convergence, convergence, not convergence. This question is from the sequence of function. Okay. To analyze these questions, first of all, we have to calculate. Let us calculate it. Here, the sequences function is defined in this way: fn x equal to nx by 1 plus n square x square. Okay, if x equal to 0, then no doubt fn x tends to 0 as n tends to infinity, because the numerator will be 0. Okay, if x not equal to 0, then calculate the pointwise limit n tends to infinity. Fn x will be what? It will be limit n tends to infinity nx by 1 plus n square x square. Okay, if we take n square x square, if we take common, okay, not common, okay, this limit, no doubt this limit will be less than equal to limit n tends to infinity nx mod divided by 1 plus n square x square mod. Okay, you will take the modulus is a bigger quantity. This is also less than equal to limit n tends to infinity n x mod less than equal to n square plus n square x square. Okay, means n square x mod square, because in the denominator part we are removing 1, because it is a bigger quantity and n square x square is a smaller quantity. When the denominator is a smaller quantity, then the whole quantity is a bigger quantity. Okay, if we cancel n and x mod can be cancelled because x not equal to 0, then finally we will get limit n tends to infinity 1 by n x mod. When n tends to infinity and x is a non-zero quantity, so it gives 0. Okay, means limit fn tends to infinity less than equal to 0 is coming, and we can also get that 0. Okay, if x is any interval containing 0. Okay, this explanation is not looking like more concrete, but we can simply calculate also its limit. Okay, let me simply calculate it. Limit n tends to infinity nx by n 1 plus n square x square. Okay, if we'll take n common, limit, if we'll take n common, it gives nx divided by n times 1 by n plus n x square. N getting cancels, and the limit simply pass to the denominator, and this quantity gives 0 and this quantity gives infinity, and we will get something like x by infinity, which is equal to 0. So the pointwise limit of the function sequence of function fn x equal to 0, limit n tends to infinity, means it is a 0 function. This is identical equal to 0 function. Okay, but in the question it is given that uh, there, there is always every time in any interval containing 0, means this question is asking whether this sequence of function is converging uniformly on which domain, means in every domain 0 is already there. Okay, if 0 is already there, and no doubt it is a pointwise convergent function. This function converges to 0 function pointwise in the sense of pointwise, but not uniformly. But the to know whether a function converges uniformly, we have to check that fn x minus some 0 minus 0 function modulo supremum value supremum x belongs to that interval, something interval which contains 0. This quantity should goes to 0, but this quantity cannot be goes to 0, because if we take x equal to 1 by n, this sequence we can take, because this quantity converges to 0, and 0 is in our interval, because in the question itself given that 0 is in our interval, so this x we can take. Okay, if we will take x equal to 1 by n, then calculate fn x equal to nx by 1 plus n square x square, and so fn 1 by n gives n times 1 by n 1 plus n square 1 by n square. This cancel, this cancel, this cancel, this cancel. Okay, so it gives 1 by 1 plus 1, which is equal to 1 by 2. So therefore fn 1 by n minus 0 functions, this quantity gives 1 by 2 always. This quantity does not goes to 0 when n tends to infinity. So supremum value cannot be 0. Therefore this sequence is a pointwise convergent sequence, but does not converge uniformly. Okay, let us verify the options. Therefore the correct answer is uniformly convergent. This is not true. Not uniformly convergence, this is true. Convergence, this is also true. Not convergence, this is not true, because it is pointwise convergence. No doubt it is pointwise convergence, but not uniformly convergence. Not uniformly convergence means it is saying that it may be pointwise convergence and not uniformly. So the appropriate answer is B. But C is also true, but the more appropriate answer is B in my opinion. Okay, let us move to the question number 31. This question is simple. This limit can be written as limit n tends to infinity 1 by n summation k from 1 to n k by n whole square. And this type of quantity, by using the Riemann definition of Riemann integrable function, this is converted to integral from 0 to 1. K by n is converted to x, and 1 by n is dx, x square dx. Okay, if we integrate, we will get x cube by 3, 0 to 1, and gives 1 by 3. So the correct answer is option B. Let us move to the question number 32. If the set E subset of AB closed interval is measurable, and if C and D are in open interval AB such that C less than D, then CD is, but there is no connection between the CD closed interval and the measurable set E. This question is not also complete, looking like something incomplete, because any closed interval is measurable and its measure is D minus C. Okay, so it is a measurable subset, no doubt. Only outer measure exists, only these are not true. But this question is also not standard question, because it has nothing to do with the measurable set E. Okay, let us move to the question number 33. Given that for any two partitions P1 and P2, this is the Riemann lower sum, this is the Riemann upper sum. Okay, we know that Riemann upper sum is always greater than equal to Riemann lower sum. It can be equal to, for the constant function, lower sum and upper sum both are equal. This is true, but we cannot. Sometimes lower sum or upper sum may be both same for the constant function. So this cannot be true. This is not true. Riemann upper sum is usually greater than equal to the lower sum. Okay, this quantity is true. This is false. Let us move to the question number 34. In question number 34, it is asking about every finite subset of any metric space is what? This is a standard result in metric space, that every finite subset of any metric space is compact. So the option D is true. Okay, we can also prove it. Why this is compact. Let us move to the proof part. it is a simple proof. Okay, finite subset means let S equal to a1 a2 dot an. These are the finite number of points which will prove that S is a compact set. What is the meaning of the compact set? Definition of the standard definition of the compact set is every open cover alpha belongs to I V alpha. This is a open cover and these V alphas are open set. Every open cover has a finite subcover. No doubt this open cover has a finite subcover because S subset of V alpha and S contains the finite number of points a1 a2 an. So therefore this implies that AI belongs to some V alpha I for I from 1 to n. Okay, means a1 is belongs to S and S is covered by V alpha, so a1 should belongs to some open set V alpha I, V alpha 1, and a2 belongs to some open set V alpha 2, like that. Okay, this means that S can be covered by union of I from 1 to n V alpha I. So we take an arbitrary open cover and we get a finite subcover. So this is a compact set. Okay, therefore every finite subset of a matrix space is compact. Not and compact set is close bounded. Okay, so not bounded is false, not bounded is false, not closed is also false, not compact is also false, and the correct answer is option D. Let us move to the question number 35. Every bounded infinite subset of R has dash. This question is from the Bolzano-Weierstrass theorem. Bolzano-Weierstrass theorem states that every bounded infinite subset of R to the power n or R has a limit point. Okay, has no limit point, false. Only one limit point. It may have more than one limit point. It is not saying that it has unique limit point. Only one limit point is also false. At least one limit point, this is one. At least one limit point is there. Has two limit points, this is also false. Maybe more than two limit points, maybe one limit point, but at least one limit point it should have. Okay, let us move to the question number 36. A subset S of the set of real numbers R is compact. Compact implies that it is both closed and bounded. So S is closed, true. It is not out, true. S is bounded is also true. S is closed and bounded. This is more appropriate. This includes both A and B. Compact means it is both closed and bounded. It is also from the Bolzano. Weierstrass theorem also gives this one. Okay. S is not closed, not bounded. This is false. Let us move to the question number 37. A bounded function f having finite number of points of discontinuity on AB is not differentiable. This is looking like true because if a function is discontinuous, the discontinuous implies that it is not differentiable. This is not true. Differentiable on AB, this is false. Not integrable on AB. Bounded functions which is finite number of discontinuity, but from the Riemann integration we know that if a function is bounded and it is finite number of discontinuity, then it is integrable. So this is false. It is integrable, it is true, but this question is asked from the integration, Riemann integration. So from that point of view, both, no doubt both A and B are true, but from the Riemann integration, this question mainly asked on the topic of Riemann integration. So the more appropriate answer is option D. But in my opinion, both A and D are true. Let us move to the question number 38. If f is a non-negative function whose integral value is equal to 0, then its function is exactly equal to 0. We can prove it. The option A is true. Let us move to the proof part. Given that integration of f of x a to b dx equal to 0 and f is a non-negative function. Okay, claim is f is identical equal to 0. Okay, proof. We can prove it by contradiction method. Suppose SPPO Yes, suppose f not identically 0 means there exist a point x0 belongs to a b such that f of x0 not equal to 0 means not equal to 0, or you can write it f of x0 equal to c and c is greater than 0, and c is greater than 0. Okay. But from the definition of from the a continuous function has property that if f of x0 equal to if f of x0 let me write properly. Continuous function has property that if f of x0 equal to c which is greater than 0, this implies that we can find a neighborhood such that f of x0 greater than c by 2 for all f of x not x0, wait, f of x greater than c by 2 for all x belongs to x0 minus delta to x0 plus delta. In this interval we can find a small neighborhood, means you can conclude it from the graph. This is a continuous function. If this value is this point is x0 and it is giving that f of x0 which is equal to c, and if this distance is c then this distance is c by 2. Okay, you can find a neighborhood, this neighborhood. If we consider this neighborhood, all these points in this neighborhoods are greater than c by 2. Okay, this is a standard property, you can prove it also. So by using this property we can find a neighborhood. From in this neighborhood f of x value is always greater than equal to c by 2, greater than equal to c by 2. Okay, then let us move to our integration part. Integration a to b f of x dx which is equal to 0. Okay, this quantity is less than equal to, because f is a non-negative functions and we are shrinking our domain from x0 minus delta to x0 plus delta. This quantity is a subset of ab closed interval. So from the definition of the integration, this quantity will be less than equal to f of x dx. Okay. Wait, no, this is not true. This is not true. I am writing the reverse inequality. This quantity is bigger than x0 minus delta to x0 plus delta f of x dx. Okay, and this quantity is also bigger than, because f of x greater than equal to c by 2. If we will put f of c by 2 in place of f of x in this interval, f of x greater than equal to c by 2. Okay, then this quantity will be smaller, x0 minus delta, this quantity will be c by 2 dx. Okay, then this its integral value gives c by 2 into x0 minus delta x0 plus delta, then this quantity will gives 2 delta, then we will get c delta which is strictly greater than 0. Okay, but here the contradiction is coming. This quantity is equal to 0 and this 0 is greater than 0, means we are getting 0 is greater than, this is a contradiction. So in this way we are getting contradiction. This contradiction is coming due to we assume that there is a point x0, at this point x0 it is strictly greater than 0, means it is non-zero. This is giving the contradiction. So this function is identical equal to 0. Okay, therefore the only correct option is option A. Option B is false, option C is also false, option D is also false. Let us move to the question number 39. It is asking about the series of functions. A series of functions fn summation of fn converges uniformly on AB if there exists a convergent series summation of mn of positive numbers such that this is a standard questions. If this series convergent and each fn is less than equal to mn, then this fn series is uniformly convergent. Okay, and this fn less than equal to mn, we have to verify this one. Okay, fn x modulus like that. Okay, less than equal to mn, then option B is looking true. This is not true, option A, and strictly not required, less than equal to will be work. Okay, this is also false, so option B is true. Let us move to the question number 40. This is the last question from the real analysis. Let us move to the question number 40. In this question, x is lie in -1 to 1 and we have to calculate the value of this series. This is a nice question. Let us calculate the value of this series. If we will give a name of this series is f of x, it can be written as 1 by 1 plus x plus 2xy 1 plus x square, like dot dot, or given that 4x cube by 1 plus x to the power 4 dot dot. This series can be written in this form: d of 1 plus derivative of 1 plus x divided by 1 plus x. Derivative of 1 plus x is 1. This in numerator part, derivative of the denominator is coming. Okay, d of 1 plus x square. Derivative of 1 plus x square is what? 2x. So it can be written in this way: 1 plus x square. Like that, derivative of 1 plus x to the power 4, like that, 1 plus x to the power 4. So if we will integrate this function f of x from 0 to x, okay, let us integrate from this function f of s ds will be equal to f of s ds will be equal to, this function can be rewritten in summation form also. Summation summation k from 0 to infinity d of 1 plus x k from 1 to infinity, no, k from 0 to infinity, 2 to the power is 2 to the power k, 1 plus 2 to the power k divided by 1 plus x 2 to the power k. Okay, this is the summation form. Okay, and if we'll integrate from 0 to x, then we'll take a dummy variable like s. It should be s ds. Okay, then this integration value will gives k from 0 to infinity. Integration value will be, if you take, this is u and it is du by u, integration is ln u, ln 1 plus s to the power s into whole to the 2k, and this is from 0 to x. Okay, if we will put 0, if we will put x, it gives summation k from 0 to infinity ln 1 plus x to the power 2k 2 to the power k, and if we put 0 in place of s, that it gives ln 1 is 0. Okay, this is vanishes. Finally we will get this one, and the summation of the ln means it gives ln 1 plus x plus ln 1 plus x square plus ln 1 plus x to the power 4, like this series will come. Okay, but we know the property of the logarithm. Ln, if there is addition in the logarithm, then it can be written in product. That gives ln 1 plus x 1 plus x square dot 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 dot, oh, like this. Okay, this is a product in the form of product. Okay, and if we will multiply or divide ln 1 minus x in the product 1 plus x, okay, dot dot, okay, 1 plus x square 1 plus x to the power 4, like this, or divided by 1 minus x. We are multiplying in 1 minus x in the numerator and dividing 1 minus x in the denominator, so the value will be same. Okay, Then in the numerator, if we calculate the numerator, let us calculate the numerator part. 1 minus x, 1 plus x, 1 plus x square, 1 plus x to the power 4, 1 plus x to the power 8, like this series. Okay, if we calculate it, it gives 1 minus 1. If we calculate product of two terms, it gives 1 minus x square, 1 plus x square. Okay, like this, and it is 1 plus x to the power 4. Okay, then by multiplying two terms we get this one. By multiplying this and this two terms, we will get 1 minus x to the power 4, and here already 1 plus x to the power 4 is already there. Okay, like that. Then if we calculate, keep going calculating in this way, finally we will get this 1 minus x to the power 2 to the power n. And if you take n tends, if this is infinite series, we have to take limit n tends to infinite. Then we will get this quantity goes to 0 because x modulus less than 1, because x lie in minus 1 to 1. In the given question it was given that x lie in minus 1 to 1, so this quantity goes to 0, so it gives the value 1. So the product of this infinite series gives 1 in the numerator part. So finally we are getting that integration from 0 to x fs ds is equal to what? It is equal to, in the numerator it is giving 1 ln 1 by 1 minus x. This is, then if we differentiate again, we have to calculate the value of fx. Then we have to differentiate by using the fundamental theorem of calculus. If we differentiate this thing, integration from 0 to x fs ds, and this gives the derivative of this one. Derivative of this one will be 1 by 1 minus x times the derivative of this one. This gives minus 1 minus x minus 2 into derivative of 1 minus x, which gives minus 1. Okay, then this quantity will give 1 minus x, this minus 1, this minus 1 and this minus 1 getting cancelled. Okay, then we will get times 1 by 1 minus x whole to the power 2, and it will be cancelled. Then it gives 1 by 1 minus x. Okay, so final answer is this one, but in the left hand side by using the fundamental theorem of calculus it gives the f of x. So we will get f of x equal to 1 minus x. So we will finally get f of x equal to 1 minus x. So the correct answer is option A is not true. Option A is not true. Option B is the correct answer. Option C is also false. Option D is also false. Therefore, in the question, from the question 40, the correct answer is option B. Okay, today we covered all the questions from the real analysis part. Next time we will cover the numerical analysis and the differential equation part. Thank you all for this, and we will meet for the next discussion. In our next discussion we will again meet. Thank you all. Bye bye.